Today our topic is linked list. Before learning this video, please learn previous videos on linked list of this series. In our previous videos, we already learned there are three types of linked list: singly linked list, circular linked list and doubly linked list. We already learned different operations on singly linked list and circular linked list. Today we will learn operations on doubly linked list. So why we will learn doubly linked list? Because circular linked list has some disadvantages. We cannot traverse the link backward. We can go forward, means after 1000 I can get the address of the next node. After 2000 I can get the address of the next node by this next part. But I cannot get the address of the previous node. So we cannot traverse the link backward. Given a node P, if we want to delete it, we have to traverse the total list in order to get address of the node that precedes P. Say I want to delete this node, the node address is 3000, that is P. Now after deletion of this node, the next part of 2000 should be this 4000 because I delete this node. But how can I get the address 2000? I have to traverse the whole linked list till we get the node whose address is 2000 and then I give 4000 to the next part of 2000. So for getting this node 2000, we have to traverse the total list in order to get the address of the node that precedes 3000. That is another disadvantage of circular linked list. So to remove these difficulties, we have to study a new linked list called doubly linked list. So what is doubly linked list? In this linked list, each node contains three fields: left field, info field and right field. Left field holds address of the previous node and right field holds address of the next node. So this is the structure of a single node. So what should be the data structure of a node in a doubly linked list? I use one structure. Name of the structure is node. Here say info is integer, so int info, and I declare two pointer variable left and right. Left can hold address of any node, right also can hold address of any node. So how we can declare these two pointer variable? In this way: struct node star left, struct node star right. Means left can hold address of any node, right also can hold address of any node. Doubly linked lists are of two types: linear doubly linked list and circular doubly linked list. First we will learn linear doubly linked list. In this doubly linked list, the left field of the first node contains null and the right field of the last node contains null, and the external pointer contains the address of the first node. In case of circular doubly linked list, the left field of the first node here contains the address of the last node, that is 4000. Left field of the first node here contains the address of the last node. And the right field of the last node here contains the address of the first node, that is 1000, because it is circular. And the external pointer contains the address of the last node because it is circular linked list. So in case of doubly linked list, if in a doubly linked list, if P be the address of a node, say this node address is P, that is P is 2000. Now the condition is P equals to P arrow left arrow right. So P arrow left means 1000, means this node. Arrow right means what? 2000, means again P. Also P arrow right arrow left. P arrow right means 3000, means this node. Arrow left means 3000, arrow left means 2000, means again P. Now we will learn different operations on linear doubly linked list. Our first operation is insert at the end of linear doubly linked list. See the discussion first. Insert at the end of linear doubly linked list. So this is one doubly linked list and this is linear doubly linked list because left part of the first node is null, right part of the last node is null and external pointer holds the address of the first node. Now I want to insert our newly created node at the end of this linked list. So this is our newly created node. Say this node address is Q and I want to insert this node at the end of this linked list. So function name is end insert. Here I am passing the address of external pointer, that is this 600, and num, that is num is our newly created node's info part. That is, this node info should be num. Say the value of num is 55. Struct node star p star q star r means p, q and r holds the address of any node. P equal to star ext means value at ext should be p. Value at ext means 1000. 1000 should be p. So p equals to 1000. P holds the address of our starting node. Now I have to create the node using malloc. So malloc allocate at the time of run struct node size memory chunk, and it returns the initial address of this memory chunk to Q. So Q arrow info should be this 55, that is num. Now first case, if our external pointer holds null, if star ext equals to null. If it is null, means what? If it is null, means no node is there. Our linked list is empty. So our node is the first node of that linked list. It is the last node of that linked list. It is the only node of that linked list. So Q arrow left should be null here because it is only one node. And Q arrow right should be null here. And star ext here in place of null, here you have to give our newly created node's address, that is Q. In this way, you can add our first node to the empty linked list. Else not empty means in our linked list there are some nodes and I have to add our newly created node at the end of this linked list. So I have to traverse the whole linked list till we get the last node, and when I get the last node I have to add our newly created node. So I start one while loop. While p arrow right not equals to null, p equals to p arrow right. First time, is p arrow right is null? No, p is 1000 and p arrow right is 2000. No, it is not null. So p equals to p arrow right. So p is this node. Again check, is p arrow right is null? No, p arrow right is 3000. Then p equals to p arrow right. So p is this node. Again check, is p arrow right is null? No, p arrow right is 4000. So p equals to p arrow right. So p is this node. Again check, is p arrow right is null? Yes, p arrow right is null. So this condition false. So come here, q arrow right should be null because this is our new last node. So the right of this node should be null. And q arrow left should be this p. Why p? Because this is our previous node of Q node. So Q arrow left should be P, and P arrow right should be, in place of null, here it is Q, because this is the next node, Q is the next node of this P node. In this way, you can add a new node at the end of our linear doubly linked list. Our next operation is delete the last node of linear doubly linked list. See the discussion first. Delete the last node of linear doubly linked list. This is one linear doubly linked list. The external pointer holds the address of the first node and I want to delete the last node from this linked list. So function name is deleted. Here I am passing the address of external pointer or header, that is this 600, and the deleted node info part should be returned because all infos are integer. So the deleted node info part is also integer. So the return type is integer. Here I declare one variable x, that is integer, and struct node star p star q. P and q are two variables that can hold address of any node. P equal to star ext, that is value at ext, that is 1000, is stored in p. So p points to the first node, that is first node address stored in p. P holds the first node address. Now if p equals to null, p equals to null means star ext equals to null, means if p equals to null, or we can say if star ext equals to null, means external pointer holds null. So no node is there. So linked list is empty. Then deletion is not possible. So just write one printf statement, linked list is empty. Otherwise, if there is only one node. How you can check there is only one node? If P arrow right is null, P holds the address of the first node and P arrow right is null, then we can say there is only one node. So after deletion of this node, no node is there in our linked list. So external pointer holds null. So after deletion of this node, star xt should be null. X equals to P arrow info. So what is X? X is P arrow info, that is this 11. Free P. I have to deallocate this space. I have to delete this node and return X. I have to return this 11. And the last case is all nodes are there. I have to search the whole linked list till we get the node whose next is null, that is the last node, and I have to delete that node. So I start one while loop. While P arrow right not equals to null, initially P holds the address of the first node. So this is P. Now check. While P arrow right not equals to null, is P arrow right is null? No. Then P equals to P arrow right. So this is our new P. Again check. Is P arrow right is null? No, it is 3000. So P equals to P arrow right. So P is this node. Again check. Is P arrow right is null? No, it is 4000. So P equals to P arrow right. So P is this node. Again check. Is P arrow right is null? Yes, P arrow right is null. Now what you have to do? So I have to delete this node. So P arrow left arrow right should be null. P arrow left means 3000 means this node. Arrow right means here, because this is our new last node now. So this node should be here. It is null. So P arrow left arrow right should be null. And X equals to P arrow info, that is 44. Free P. I have to delete this node, deallocate this space and return X. Return 44. The next operation is display of a linear doubly linked list. See the discussion. Display of linear doubly linked list. So I want to print each and every node info. So function name is display. I am passing the address of external pointer or header, that is this 600. Struct node star p, p can hold address of any node. I give p equal to star ext, that is value at ext 1000, so p is 1000. Now till p null, I have to traverse the whole linked list and print each node info. So while p not equals to null, first time is p is null, no it is 1000, then printf p arrow info. So first print 11. After printing 11, p equals to p arrow right. P arrow right means 2000, so our new p is this node. Again check. Is p is null? No, it is 2000. Printf p arrow info. So print 22, p equals to p arrow right. P is the right of current p, that is p is now 3000. Again check. Is p is null? No, p is 3000. Printf p arrow info. I am printing 33. P equals to P arrow right. P is now 4000. Again check, is P is null? No, P is 4000. Printf P arrow info, that is 44. Print 44, P equals to P arrow right. P arrow right means P is now null. When P is null, this condition false. So after printing our linear doubly linked list, we can get this result. C program to implement following operations on linear doubly linked list. First, insert at the end of the linear doubly linked list, delete the last node of linear doubly linked list and display the whole linked list. See the program. So this is our program. This is node structure. These are required prototypes of our functions. This is main. Initially, I initialize extptr as null because no nodes are there. So extptr contains null. This is one index. I start one do while loop. Case 1 is end insert, case 2 is end delete, case 3 display, 4 exit and 5 default. Take the choice from the user. Here I use switch case control statement. Case 1 is end insert. Take how many number of nodes user want to insert, say it is end, then start one for loop for I equals to 0, I less than in I plus plus, take the info part of each node and call end insert function by passing the address of extptr and the info. Case 2 is delete function. Here call the function delete by passing the address of extptr. This function returns the deleted node info part and I print that part. Case 3 is display. Call the function display by passing the address of xdptr, case 4 exit and then default case. And these are required functions. First, this is an insert function we already discussed. This is display function we already discussed. And this is delete function. So when I run the program, first see, supply your choice. I want to create the linked list. So insert function, called insert function. So choice number 1. Supply the number of nodes you want to insert, say it is 5. Supply the info part of the first node, say it is 11, then second node it is 22, then 33, then 44 and then 55. Delete. Call the function delete. Before that I want to see our total linked list. So case number 3. So this is our linked list. Now delete. I want to delete the last node. So case number 2. So the deleted node info is 55. Now again I want to see our whole linked list. So case 3. So this is our linked list now. And finally case 4, that is exit. So this is your programming assignment. Write a C program to implement following operations on linear doubly linked list. First, insert at the end of linear doubly linked list, delete the last node from linear doubly linked list and display the whole linked list. Linked list is very important topic for your campusing. There are some interview questions on doubly linked list. Try to answer this question in the comment section. I am waiting for your reply. For getting more and more updates, please like, share and subscribe my channel. That's all for today. Thank you.